Okay, guys, thank you for joining. This is 101 blockchain class introduction and how we use it at Decentraland. I'm Nacho. I'm a co-developer of the project, working in the dApps team. And well, let's start with talking about a little bit how a blockchain is. A blockchain basically is a distributed database, and maybe you're wondering what is a distributed. Distributed is something that we can see in this image. You can see, for example, for banks, and each bank has its own ledger. And once someone in the banks, for example, create a transaction like Nacho paid $10 to Bob, this update will be distributed and also will update all the ledgers all of the other banks. And also a database is not something important that we are going to talk about today, but we can see it the database as a ledger. So we can see blockchain as a distributed ledger where these transactions that we are going to do in the lecture will be stored in blocks, and each block has a limit size. So for example, in a block we can store an amount and a fixed amount of transactions, and uh, once we fill all the amount, for example, the block can has, I don't know, maybe 10 transactions, and once we fill all the amount or all the size of the block, a new block will be created in order to store 10 transactions, and then another block will be created and will be there also 10 transactions and so on. And each block is sequentially added in the chain. So no blocks can be modified. So the blockchain is immutable. So for example, if we register a transaction in the block one saying that Nacho paid $10 to Bob, there is no way to modify that transaction. So once the transaction is there, will we keep it there for forever? And one of the things that you can do in the blockchain is to query or fetch or look for every transaction that everyone's made. So this is not private, it's always public. So if you, as I said, if you want to, for example, get all the transactions that I made, you can do it. It's not that easy that look for transaction that I made as Nacho, but because as we know, we have addresses or accounts. But if you know the owner of an account, you can check all the transactions that account made. So that is why the blockchain is also anonymous, because you have this address or account that doesn't represent you as a citizen of anywhere. So other property that the blockchain has is that it doesn't have an admin. So the as we can see in the image, there is not a centralized entity that allows or gives permission to the other banks that are here. We can call them nodes. And for example, if we can see the image in the first row as node 1, node 2, node 3, node 4, anyone can make an update of the ledger and communicate that update immediately to the other ones. So anyone can create a new transaction or can set a new transaction on this blockchain. Also, one of the other properties that the blockchain has is that how you can make, for example, can follow the full chain of the blocks. In order to do that, each block, a consequence block, has the hash of the previous block. And maybe you are wondering now how a hash is, and I will help you with that. For example, let's imagine that a hash is a function. A function could be something like, for example, when you try to log in at maybe Google, you use a username and also use a password. That information, your email and password goes to a server, and the server executes a function. That function check if the username is not empty, if the password is not empty, and if there is if there is a match with that information in the database. If a match is there, it will return your information as a user, and if not, it will return an error. So a hash function is also something like that, and it's a function that is used to map arbitrary data size to fixed data sizes. For example, if we see in this image, we have the input of Fox, and if we apply, no matter what, how is implemented this hash function, it will return a hash, and this hash is has a limit size, a fixed size. And for example, if we do the same for the red fox runs across the ice, it will return another hash, but with the same length as before. And if we use, for example, the same length of the input, but with another word or another phrase, it will return another hash, but also with the same fixed length as the other ones. So why we in blockchain is used a hash function? Because of that, because we can have all the information or all the transactions, and we can hash all together, and it's always, no matter if the transactions are 10 or 20 or 2000, it will always return the same hash length. It will have different values, but the length will always be the same. So as I said before, every block has its previous hash, and that is the way that you can link all the blockchain. If you start, for example, with the latest block, which here is the block N, you will see you will have the previous block hash, and if you do that and you can do that until the block 1. The blockchain is also cryptographically secure. That means that basically of cryptographic algorithms and and its security, nobody can break it in a way. And all of, for example, all of this, I don't want to talk about mostly of cryptographic, but for example, one of the things that you need to have in mind is that in the image of the hashes, if I get the hash sum, I cannot get the original input. So the hash is something that it's called one-way one-way function or something like that. So there is no way to go back from the result. So also in blockchain, something that is really cool is how if the ways that the blockchain has to start creating new blocks. In the Bitcoin blockchain and also in the Ethereum blockchain, it's something that's called proof of work, and there is a game theory behind that, which is a game to find a number. And this number is the nonce. Is a number that only used once. In order to get that nonce, all the different miners that there are around there are trying to find a number that, based on that number, will return a target value, and that target value is something that is imposed by the blockchain itself. So the blockchain says, okay, let's try to find a nonce that, if you apply that nonce in a hash function, will return this value that I said. And in order to do that, all the miners start using its computer power to start doing a try and error test. So once the first one find that number, the the blockchain rewards that user to coins. For example, in the blockchain with Bitcoin, the miner that found the nonce will get in rewards Bitcoins, and in Ethereum will get Ether. Also, maybe you're wondering why or how these things that we saw before are related to if one of the nodes can make an update. What happens if two nodes at the same time made a different update to the same record? For example, something that is called a double spending. Maybe we can see it like I only have $10 and I pay $10 to Bob and $10 to Bob to Rob. So this is solved by something that is called consensus algorithm. It's super hard to understand the fundamental of that, but basically it's an algorithm that prevents this kind of double spending using things related to make it's an algorithm using in distributed systems like a blockchain, and it's always return one valid transaction. In the case that I send my only $10 to two different people, only one of that transaction will be set or stored in the blockchain. The other one will be rejected. Also, the blockchain has something that is called a difficult level. Each block has a difficult level, and this difficult level is related to the time that a block that a new block appears in the blockchain. And this difficult level is changing every 2 weeks, because every time new miners start working or helping in the blockchain to add new blocks, and it's used in a way to not start mining or validating block too fast. So each 2 weeks, for example, in the Bitcoin blockchain, the blockchain itself adjusts automatically this difficult level. So every block can appear every 10 minutes. Something that I forgot to tell you about is what is a miner. A miner is a software or hardware or a person that has a powerful hardware to validate blocks. How these validations works? Well, this is related to the game theory to get the nonce. If you have more hash power, it means if you have more hardware, you will be able to do more try and errors in a period of time than the other ones. So a miner is someone that has maybe a good computer or good hardware, and download, for example, a program and connect to the blockchain that he wants to start being as a validator, and then everything's happen automatically. Every time that the blockchain wants to add a new block, it will create that target hash that the miners need to find, and every miner will start with this game. And once the first one found that nonce, the block will be added to the blockchain and distributed to the other participant, which are the other miners. Well, as also something that I said before is that the block has is unmutable, and the only thing that for a block has is log of changes of the previous one. Okay. As we are using the Ethereum blockchain, I will talk about a little bit about this one. Something that is pretty cool related to the Ethereum blockchain is that generalize the concept of state and transactions. And in for example, Bitcoin doesn't have this way to run arbitrary code on its blockchain, and Ethereum's break everything up because of this concept called smart contract, which are programs that run in the blockchain. So that is why the Ethereum has this state and transactions blocks. The coin of the Ethereum blockchain is the Ether. The minimum is the smallest denomination of Ether. It's called Wei, and the gas to pay for computation. For example, if you remember when you want to send a transaction, you have something called gas price, and this gas price is in a denomination or symbol which is Shiwei, which is 1.9. And also one thing that is really important related to Ethereum, and that is why, for example, we are trying to adopt Matic, is that there is no interoperability between blockchains. It means that I cannot send a transaction to exchange, for example, swap Ether to Bitcoin, because Bitcoin is a coin for another blockchain, and there is no way to communicate between blockchains. Well, this is how you can see the whole state of a transaction in the blockchain, in the Ethereum blockchain. The first thing is that, for example, let's imagine that we want to transfer one Ether to another account, and the first thing that you need to do is to sign your transaction. You as an owner of a wallet, you have a private key and a public key. Your public key is your account or your address, and the private key is something that is stored for example, in your computer or your Chrome extension or whatever. So if you are using, for example, MetaMask, you will sign that transaction, and this transaction will go to something that is called the mempool, which is the transaction mempool, which is, for example, you can see it here as a swimming pool with all of the transactions that people have signed, and the miners will pick the transaction from this pool, and then if everything is okay, that transaction will be included in a block. How miners are prioritizing how transaction they will get, they will prioritize based on the gas prices. I don't know if you are if you remember, but this week the gas prices go really up from, for example, 2 or 3 Shiwei to maybe 40 or 30. So if you send a transaction, basically if you send a transaction with a gas price of 2, when miners are getting only transactions from 10, your transaction will stay in the pool for a really long time. And if you want, for example, a transaction to be mined first or mined fast, you need to use a high price, because this price is the reward that the miners will get. When you need to send a transaction, you need to set the gas that the transaction will use. The gas is like a fuel, or you can say fuel, and the miners will see as a computation power, but you can see as a fuel. For example, let's use 10 gas to do this transaction, and I will pay for each unit of gas, I will pay 10 Shiweis. And with this, with that math operation, the miners will calculate how much they will earn as a reward if they validate your transaction. And that is why the gas price should be higher if you want to call the attention of the miners to get your transaction validated. Okay. Then let's talk about a little bit how an account is used in Ethereum. An account is basically 20 bytes, and we have an example here. Each 2 characters you will need to count as a byte. So this string of characters has a long of 42. we can see 40 because the 0x is not counted. And in Ethereum, you have two types of accounts. The first one is an external account, external owned account, which is controlled by a private key, the one that I previously said. And also you have a contract account, which is what we call a smart contract. It's a program, and it hasn't a private key. So if we see in the image, we can see that, for example, in the blockchain itself, where the information is stored, an external owned account, which is the one that you have in MetaMask, has this address, which is the identifier, and has a nonce and a balance. This nonce is not the same as the nonce that the miners use to validate the block. Is related to the number of transactions that you sent. For example, when you start, your address has non-zero, and when you send a transaction, your address will have nonce one, then the other one nonce two, nonce three, and so on. And also this address has a balance in Ether. And then we have this contract account, that the only difference between the external owned accounts is that this kind of account has a storage hash and a code hash. This is something that we can see as a little program, that this program has code and also use storage of the blockchain to save, for example, a variable. If we want to remember how, for example, how the mana how mana works, we have the mana contract has its code and also has its storage. So in this storage, you will have something that your account, your address has this mana balance. So remember that the balance that we have here is Ether balance. It's only for the coin of the blockchain, not for the tokens that lives in the blockchain. And every token is an account, but it's a contract account. And well, the sum of all accounts, the external owned accounts and the contract account, represent the system states of the blockchain. As we can see here, we have this way of doing a transaction where I send from an external owned account, I send 1 Ether to another external owned account, which is I can send 1 Ether to Rob. And also we have this kind of transaction that is the one that we are using, for example, in Decentraland, that we send transactions to contract, for example, to register a name for your avatar. And the thing that you're doing here is you send a transaction from an external owned account to a contract account, and this contract account has the ability to do internal transactions to another account. For example, when you want to register a name, you send a transaction to the ENS contract, and the ENS contract send a call or an internal transaction to the mana contract to check whether you have balance or not in order to pay for that name. Then we have a transaction has a lot of properties, and well, as I said before, the nonce is the number of transactions that you send, and it's used to avoid duplicate transactions. Then we have the gas price. This concept that I also told you before is what the sender is willing to pay per unit of gas. And then we have this gas limit, which is the max amount of gas the sender is willing to spend. Imagine that you want to transfer mana, and you know that to transfer mana you will use only 10 gas. So you set this gas limit, because if you don't that, the miners can, for example, hack and said that you use the maximum limit of gas, which enters in a block. Right now in Ethereum, I think that is maybe 8 million of gas. And if you send the transaction, for example, with a higher gas price, you will end up paying, for example, 200 or so a transaction. So as a user which are going to send a transaction, you set the gas price and the gas limit. And it's related to saying like, I will pay $10, but only for 10 units of gas, no more than that. You can use less, but you can't use more than that. Then you have the recipient address, which is the two. It can be an external owner account or an contract account. And also you have the value. The value is, for example, if you when you are sending Ether to another account, you you set a number in this value. Is the Ether that you're going to send to a recipient. And if you are sending a transaction to an contract account, and you need to pay Ether for something, for example, if it is a contract which are selling, for example, NFTs, and each NFTs has a cost of 1 Ether, you will need to send the transaction with the Ether in this property of the transaction, in the value. And also you have the data. The data is something that we're going to see later, but it's the input data of the message call. When you want, again, to call a contract, and you need you will call a function of that contract. And in order to do that, you need to send the function that you want to call, and also its parameters. We can see it a relation between what I said when you want to log in at Google. It's called a function also, which has a name, for example, sign up, and you send your email and also your password. And this is the same here. You need to specify which function do you want to call for the contract, and also the parameters that the contract will use. And then you sign all of this data with your private key, and it will return these three values, which is used as a signature. It's something that is used to be sure, and the contract or the other user be sure, or the blockchain itself be sure that the ones that is sending your transaction is you, because you should be the only one that has that private key to sign all this data. It's a way that's saying, okay, I will send this transaction. I know everything related to its properties of the transaction itself, so I sign everything with my private key, and I will send all together to the blockchain. And the miners, in order to check if the transaction is sent by you or not, it gets this signature and do the opposite. Gets is used as a recover function, where if they use all these values that you have used to sign, and also the signature, it will return your address. And this is the way that they have to know if the transaction was sent by you or not. Okay, so imagine that we have this smart contract. This smart contract is a contract account, and it's a simple program where we have this variable called last writer, and also last value, and we have only one function, which is set value, which receives a value, which is a number. And once someone's called this function, the last value will be updated to the value that passed by parameter, and also the last writer will be updated by who sent the transaction. So imagine that we want to send a transaction to this contract, and we have a pretty UI like we have in Decentraland, which make all of this, what I told before, invisible for us, and only we need to click confirm on MetaMask. What happened behind of that is this. You will see, you will get the transaction hash. You can use that transaction hash in Etherscan to check the properties of that transaction. As I said before, you have the two, you have the gas limit that you set, the gas used by the transaction, and also you have the gas price that you set. In this case, I set 27 Shiways, and also you will see your nonce, which is the number of transactions that you sent. And here you will see this input data that I told here. And this input data maybe and sometimes is weird and can and you can say that you don't understand anything what I did, and it's super simple if you know the method of the contract. For example, this is the input data that we saw in the transaction, and this is it's divided in this way. The first 8 bytes, the first 8 characters, will be the function signature. The function signature is the hash, is the first 4 bytes of the function, but passed by a hash function. I will say that again. You have a hash function that the ones that we saw at the beginning of the talk, and if you use this string set value parentheses un parentheses to that function, it will return a hash, and that hash you will only get you will only need to get the first 4 bytes, and this is put at the beginning of the input, and then the last part of the transactions is the value that you send to it, this parameter, the parameter value. Each value, in this case, the value is a uint 256, which is with the 256 is the bits that will use this value, and is 32 bytes, so we can see everything as bytes. And we have a little map of things here. This is the typo. It's 32 bytes equal to 256 bits. And 2x, as I said before, is 1 byte. So in the example of 00, we have 1 byte. And in the example of 0080, we have 2 bytes. So in this example, I'm sending a number padded to 32 bytes. And this value is 38 in hexa, which is the one that is used in Ethereum. It's not decimal, it's hexadecimal. And I will try to say to help you again with the set value thing. How is it done? Is in this way. We have this hash function, which is called, as you see here. And if we pass this string to this function, it will return a hash. If we put here again a string with a long length, it will always return the same different hash, but with the same length. So for the output of this function, we are only getting the first 8 characters, which represent to the 4 bytes of that function. So basically here we are saying that call this function, and this function is this piece of the transaction is called the selector. So call this function with this parameter, and that's all. It's everything. Then the contract and the virtual machine understand that you're trying to call this method, which is set value, and you are using this value as a parameter. Then we have a question section, so we can deep on this. And well, in Ethereum we have right now, and the ones that we are using at Decentraland, we have these 2 standards. The one is the RC20, which is fungible tokens, and every token is equal to the other one. For example, the mana contract, 1 mana is equal to another mana. And then we have the RC7021, which is non-fungible token. Every token has its unique ID, which makes it different from the other. As you can see, we have the lands and states. Now we have wearables. a name that the name that you're using in your avatar is also on RC20, RC7021. Sorry. This is how, for example, the mana token it's looked like. It's a program also as the other contract that I showed you before. And we have these three variables, which is the symbol, which is mana, the name, decimals, and also we have this function that is called by everyone, which is the transfer function. And then we have this how, for example, the land contract looks. We have, for example, when you want to transfer land from another one, you are calling this function of the contract, which is transfer from, and is saying that I own the land, so transfer from me to another one, and you are sending or specifying the land ID, which is the token ID here. So I know that maybe there is too much information, and it's the first one I made this class in English, so maybe I forgot a lot of things. So it's time to shoot and ask me the question that you have. Well, I think that thanks everyone, and I hope that the talk was helpful for you. And if you have any question, I'm on Discord, or you can also ping me by Slack.